Hello, everyone. This presentation will focus on data analysis regarding time. Through this presentation, I will address some of the things, including what is the importance of time and data analysis in health data. Also, what are the tools and packages that are used time analysis, and also how can we convert data into other formats so we can do analysis, for example, from date of birth and also duration between dates, for example, service date, months, years, and vaccination date, disease onset, disease birth and disease onset. So how we calculate time differences. So we'll see how can we in different contents, for example, year, month, day, different units of time measurement, and how can we extract that different time measurements, our data analysis options. So we'll see those and also visualizations by different contexts, for example, by age distribution, by trend, and also possible to do advanced options, for example, analysis. So let's go to the data and work with the data. So we'll go step by step. So this is my data, as you see in R. Packages, for example, lubridate is one of the important package for manipulation for data-related data for time series and data analysis, and also other packages like dplyr important, and also the others are also important for different purposes, because for this, that means a kind of arc markdown to have a presentation. So have presented online the data analysis step and everything. This is by different categories, also the data outputs and interpretation. So, the reason I have these different softwares anyways is to produce this online outputs as well. So let's go step by step. So let's screen our work environment and then start by downloading some important variables and also uploading the data. And then let's convert some initial data. We'll see the missing value. There is no duplicate observations, as we see patients sorting by close one. So you will see most of the stuff. Okay. Now we see our environment, the data for patient and for vaccination data. This is the data used for this presentation is for vaccination data, which is synthetic data used for this presentation purpose. But I am also working on vaccination data analysis, and I have a real experience while working at Department of Health as data analysis for immunization for different contexts, especially during pregnancy, what is the different vaccination uptake. So this presentation is focused on vaccination. Also, there is vaccination date and there is date of birth. So presentation will demonstrate how can we use this date of birth and also service of vaccination for different purpose of data insights. So let's go to our data and also stages. So we see, for example, there is no missing value by vaccination date or by birth date, as we see here. I'll expand a bit. So it takes this one up. So, and no missing value, and the minimum and maximum value, for example, the birth date, youngest is in 1914 and the oldest is in 2023, and the vaccination date, the oldest is 1962 and the youngest is nearest or the recent vaccination is in 2024. So this is just a brief summary and also check what our data looks like. So welcome. So we are here. We have duplication and structure of the data. We'll see, especially for birth date, need to see the structure of the data. For example, at the moment, it is character forum. So we need to change that one. And also as well, I think there is a separate somewhere. So we'll go step by step. So let's observations. Once we have that, the next step be this code is to convert the math. So when we see this data, for example, date, it is a character. At the present form, we cannot do data analysis unless we converted the date. This date is date of vaccination. The date of vaccination is time zone. That means it is time as well as hour and minute. So it's presented like year, month, day, hour, minute, as well as second format. So it's really important to understand how our data looks like before going to date data manipulation. So now the next step will be converting this data into a date format. So we have birth date. So for birth date, we can change the birth date into year and format using press variable at the function at the beginning. And also for vaccination date as date, this is vaccination date, which is renamed before. Vaccination date, we can change into date, and the format is Y, month, date, and hour, and also time zone. So let's change that one, and let's see the structure now. Now the date is now the date of birth is become date variable, as you see here. Also, when we see the date is now also changes into a date format, and also we have extracted the date as well, because when we see date in this function as date, day, month, and year, this is anyways one of the important step in converting date data or into a format that we are interested in. So just for us understand what the data looks like, and the next step is converting that data, the data we want. For example, from here we can extract only hour, we can extract only minute, we can only day or whatever. So there is a different option in ways to extract what time measurement or what time unit is important for us. Then after that, once we have the data, this structure is the structure of the data. This vaccination patient is the data frame. So this is the variable of date and vaccination date. So now we can convert and we can do next data analysis steps. So this glimpse is also just the other option, or structure is the other option. They give you the same the whole data structure. That means what are the structure of different data. For example, date is now changed to date, but we'll see other variables, whether they are character or they are double or whether they are integer. Now we can see do some sum. For example, single value, or is there any minimum or maximum? And then we can also, the next step is we can do calculation for what is the age, what is the service year, calculation. So for this one, for example, date, that for example, today is 12 of April 2025. So it will consider as today, and also we technically discount from today to birth date. So it cannot be appropriate, especially it will be different based on your context. Usually, for example, for my actual data analysis, it is I'm interested to see, for example, birth year or age from the end of 2024. So you can make this one the exact date if you are interested. Anyways, you can change this one as you want. Birth date, so is in days. If we are interested to year, then we'll divide date by 665.25. If we are interested by week, we'll divide by 7. So anyways, you can work out different calculations by date. Also, floor is to make your year variable as a whole number, so it will not have decimal points. And the other is, for example, vaccination service year. So you technically from here, we are extracting from vaccination date only the year out of, for example, we have day, month, year. So we are extracting only year, this code. See some tabulation. So we have already created these two variables using mutate variables in R. And then once we have this one, let's see how our outcome looks like. So it looks like it's working, and most of examples of observations are, there are plenty of observations after 2015, but before that there are very small number of observations, and also we can see the number of observations by different age groups. The minimum is 2 years, the maximum is 111. So yeah, we can do some calculation around here. And the next one is also doing more of different units of data. For example, we can use weeks, we can use days. That means this one is 4 years. So we can play around with different measurements, and we can calculate, for example, the day, the week of vaccination, the day of vaccination, the month of vaccination, the year of vaccination, and also we can do we can also do the summary by different outcomes. Other thing is also extracting contents. For example, if we are, for example, from the previous example, we have seen the data from 19, we may be interested on some dates. This give us, for example, this is, I think, more of another date formats actually. So we are calculating actually, for example, time measurements. For example, this is season measurement. And this code gives different months, for example, January, February, April, something like that, 12 months in each year. Vaccination, and we use the date variable, that means the vaccination date, and then we each different months. So from this variable, we calculated different months, and from this one, actually where day is it, for example, Monday, Tuesday, Friday, something like that. And also this code gives us the quarter of the vaccination. And also the season of vaccination. As we know, the date has different measurements. It has days, it has hours, it has seasons, quarters, Monday, weekday, weekends. You can calculate a date with different options as we interested in our objective. So this code is more of giving a context to calculate different date contents. The other is, as we said, also extracting the dates. There is also calendar dates. Usually, for example, for a year, we can also use a financial year as well. That means, for example, financial year from to actually this should be 1st of June. Can also use financial year as well. This is actually the weekend, sorry. So we will keep as it is. And the financial year is this one. If we need financial year, we can also calculate the financial year as well. Thing is, we can also calculate date range. That means, for example, if we are interested in a certain of time, for example, if we are interested only for the year 2022, so we can extract from the first month of January 2022 to 2022. So we can extract this one, and we can call, for example, vaccination in 2022. The other is, for example, if a date range, for example, for this analysis, I mainly use 2015 to 2024, because as we see previously, most of the observations come up after 2015. So this is the option to extract and to filter out or to dates out of a chunk of dates. For example, this one gives date between 2015 and 2024, or you can extract a single year, or you can say, for example, filter vaccination date equal to 2022, or you can include the day as well. Anyways, there are different options to calculate the range between datas, but the DEM range is also important in data calculation. So let's hit this one, and our variables, as we see in the working environment, and so we also see the variables, outcome variables here as well. Let's see the variables by race, also by ethnicity. So this is just the frequency by different contents. This chunk code is to order our variables, so it will be easy to follow up. So if I open this one, get, for example, after ID, I will get birth date, birth year. What's ID, gender, race, birth rate, 2024 one. Yeah, here it is. So our data is ordered by gender, race, birth date, and other variables we created. So just we can rearrange the variables so it will be easy for us to follow. So we can also do some tabulations to see what is our variable looks like. For example, this one is one of the friendly variable that I created a good, nice table, so we can, for report purpose as well, using flex table amount or the observed the observation is in each different years for females, for female, percentage and count by, for example, we have by year, we have by quarter, and we have by weekday. That means, for example, Friday, Monday, Tuesday, something like that. Anyways, we can see the different observations and distribution of the vaccination service by different contexts, maybe by year or maybe quarter. For example, from year, we can see, for example, for females, the lowest, for example, is 74, 77. For example, this is the lowest, I can say. I think this is the lowest among females in 2024. And so see, for example, in 2023, the observation, there is observation in both males and females, high vaccination rate. But this is the different options that we can have a look by different days or by different measurements of. So this is important how we can visualize our data while doing in data analysis. Also, you can use different models. For example, G models give us also a nice way of presenting the proportion of vaccination by 6 different age groups, and also by this is weekday, Friday, Monday, Tuesday, Saturday. So this shows how importance of doing date in different contexts. So it gives different insights. For example, service interrupted and other information. So let's do some tabulation and vaccination by months. So by months, it's just divided into 3 months actually, by 3 months, year and by months. So as we see here in 2021, around 2021, there is high rate of, and then after that it just dropped. So it shows as around this time there is high or high public health interventions, maybe related with COVID, but after that it just dropped and also just comes to normal routine. Let's skip the other presentation option. I think we'll cancel this one. So if I zoom this one, so this is just by month. For example, January, February, March, April. From in March, there is, in June, there is low, and also in August there is high peak. Around December, around the end of the year, usually a low uptake of vaccination, but after that it improves. So it shows how vaccination. This is actually the count of vaccination. So it shows how the vaccination by months varies across different months. Should cancel this one to generate another plot. Might be, for example, if we are interested, like this one is, for example, in different months and different days. So how is, for example, the vaccination looks like? For example, as we see on Monday, usually slow, especially in December. This is at the bottom, the vaccination uptake. So when it is darker, it technically shows the vaccination is high. So in Wednesday, it technically shows the little bit higher enters day, a little bit higher uptake of vaccination compared to other dates. So it shows the variation of the vaccination uptake by different date as well. That means we can see, for example, the vaccination by different seasons as well, by autumn, spring, summer, and as well as winter. So higher in autumn and spring, but a little bit lower in summer and spring season. The other option of using, for example, this is a line graph that it's showing by different ethnic groups. Like, for example, as we see here, green is other. So other groups, they have high fluctuation rate up and down. It might be with different reasons. One of the reasons is their sample size is low, so usually up and down. But see, for example, white is usually a little bit consistent compared to others. This is purple line, but other ethnic groups or racial groups, there is high in vaccination coverage. As we see previously, there is high uptake and then it drops down. Then for most of the people, except for other groups, vaccination becomes flat and a little bit low at the end of the year. So this gives an insight, for example, from 2015 to over the last 10 years, how the vaccination coverage is going on. We can also use the box plot, and the vaccination fluctuates. The box plot shows how the vaccination. And the other is we can also see vaccination by sex as well. So we have gender, females with yellow and males with blue line. It shows especially except in 2018, for example, for the males are dropped, the females are a little bit higher. Most of the time, the rate increases and decreases in similar paths, but there is some up and down, especially for there is more fluctuation compared to males. But this presentation gives how the vaccination varies by time as well as by gender. So this is the presentation, how can we present and how can we work and how can we present in different contexts so we can assist making. So in this presentation, we have addressed, for example, how can we proper conversion of data. That means from, for example, if the date is a string or character, so important to convert to in date format. Then after that, we can manipulate different of date. That means different units of date, be hour, maybe day, it may be weeks, weekdays, quarters, season, year, months. So we can work around that. The other is calculation of age and also calculation of service delivery, the difference between age at service and or do some analysis around that area. We can do temporal analysis and seasonal analysis. We can also do survival analysis as well, more advanced option. So from this presentation, it's always one of the tip point I would advise is when you work on dates, it's important to check the date in valid format and also discuss with your team what is the measurement unit for the date, and also handling any missing values as well, and also understanding different date formats and the structure of the date. Is it day, month, year, or is it year, month, day, or is it another format? So yeah, thank you so much for the attending presentation. I hope you get some from this presentation, and also work on your data on date data, get some insights for supporting